Welcome to the IMSAI channel, where I try to resurrect an old IMSAI 8080 computer. So I thought we'd take a second look at this card. I showed it when I was showing a bunch of cards, but this was a hand-wired board that I built for my Centronics printer. And it's just a simple parallel bus. It has I think a 36-pin connector on it that was the Centronics interface. But I used this proto board, which was very handy. It comes with some regular routing already on it, this little section down here. There's a section that compares some address lines to a dip switch, so you can put this somewhere in memory. And if the addresses on the address bus matches the switch, then it asserts a line. And then there's an 8-bit input buffer and an 8-bit output buffer. So that's what these 4 chips are for. These 2 chips over here I added for some handshaking that's required for the centronics. And of course the card always has the obligatory 5-volt regulator. And here's the wire on the back. The data lines and a couple handshake lines to the centronics, and then the little glue logic down here at the bottom. Let's take a look at the schematic for this. This is the board layout for the GP100. Like I said before, there's one little section that does address decoding, and then there's an 8-bit data port that's buffered, and an 8-bit data port input that's buffered. So the schematic is pretty simple. There's an input section that's just some AND gates, and then there's a output section that's looks like a tri-state buffer, and then there's a comparator that takes a look at the switches and part of the data bus, the address bus, and then it creates a match signal, or actually a not match signal, inverted match signal here. So the way that I use this, this is my hand drawing of, oh gosh, a long time ago. This is when my handwriting was better. I don't think you can read it today. But how this works is the Centronics printer basically needs to give an OK. That's done with the busy signal. So if it's busy, you can't send it data, but if it's not busy, you can. So the busy signal in the upper right-hand section there goes off to the input port. So it occupies just bit 0. So to use this, you would just monitor bit 0 until bit 0 was okay. And then you were able to write a byte to the printer. And the way that you wrote a byte to the printer was over the data lines here. And there's only 7 data lines because the printer could only do uppercase. And the print is a data strobe. So down in the lower right, you see pin 1 is data strobe, and that says that there's a valid data on the data bus for the printer. So you get these signals from this little bit of logic here. There's the not match signal in the very center there, and so it keeps anything from propagating unless this card's being addressed. And then there's 2 things we need to worry about to give it a data in pulse and a data out pulse. The data in pulse is a combination of S input and P data bus in, and then the output signal is a combination between the S out, which means it's an I/O output that you're looking at. The first one is the I/O input, and then you AND that with a write pulse, and you need to invert that. So it's very simple. It served me well, kept my Centronics printer working for many years, and there you go.